in Kirkland, so the area, so a little bit north of Juanita Beach. So I am going to be so excited when we finally can start doing the sessions together on site as opposed to virtually. So hey, Harry from Bellevue, great to hear. Hopefully the weather is a little bit better in Bellevue versus in Kirkland, just because, you know, the Lake Washington weather zone that is what it is. Hey, Paul, good to hear from you again. Too bad we don't have this thing set up where we can actually chat voice wise, but you know, definitely would love to say hi to you and catch up with coffee sometime, Paul. And yes, you're from Sammamish. Woohoo! All right, let's see. We're gonna wait just a couple more minutes just to let other people dive in, and then we'll go forward from there. And meanwhile, what was it I was thinking? I'm going to do my best to answer any questions on LinkedIn. Though, like I said, I'm going to be a little bit inconsistent for the LinkedIn folks, not because I don't want to answer your questions, but only because there is, it's easier for me to see the questions directly within Zoom. Okay, so again, apologies in advance if I did not answer your questions directly on LinkedIn. All right. All right. So, but hey, for the folks who are on LinkedIn, like I said, I wasn't trying to ignore you. Go ahead and join us and say hi. Where are you from? You can do it in LinkedIn. I'm monitoring this, and you can do it in the chat within Zoom. So we can do it either way. All right. And this is meant to be a fun session for us to chat and have conversations. Unfortunately, you're going to be primarily hearing my voice, but by the same token, yeah, let's definitely chat. All right. I will try my best to answer questions as well as I can. Obviously, I'm not omnipotent, but I will do my best. Okay, so let's dive into it because we got a lot to cover today. And by the way, thanks very much to Karen. She is on the background managing all the logistics here. So I want to give a shout out to her for taking care of this. So in case you don't know, today is March 23rd, 9 a.m. Pacific. As part of the Seattle Spark and AI Meetup, we're going to talk about how Apache Spark 3.0 and Delta Lake enhances data lake reliability. It is being, for the folks that are wondering if it's being recorded, it is recorded right now. It's being broadcast to YouTube. And hey, for the persons from UK, awesome. All right, well, again, this is the session, how Apache Spark 3.0 and Delta Lake enhances data lake reliability, in case you didn't know which session you're in, okay? The one thing to note here, okay, is that we actually have a webinar. It was actually called out in the meetup. We have a webinar that actually talks about some of the stuff. We've actually updated this a little bit, number one. And number two, I did actually want people to go ahead and chime in and ask questions. That's the reason why, okay, that we're doing this session. In case you don't know who I am, hopefully the folks in Seattle sort of know who I am, but nevertheless, my name is Denny Lee. I'm a developer advocate at Databricks. Actually, I'll skip through this stuff. Basically, I'm a geek. I'm based out of the Seattle area. I used to work at Microsoft, helped build Project Isotope, what is now known as Azure HT Insight. Been working with Spark since 0.6, if I recall correctly, and been with Databricks for a while and rocking it, loving it here. So I have a bit of background when it comes to big data, data engineering, data science, because when I was at Microsoft, I was working at with the SQL Server team. And so I had transitioned us into what now is known as Hadoop and HT Insight and yada, yada, yada. All right, so that's my spiel. The cool stuff. If you don't already have it, please go ahead and download your own free copy. I apologize for sounding like a salesperson. Free copy of Learning Spark 2nd edition. All right, it's co-written by my co-authors, Jules, Brooke, TD, and myself, and a forward by Matej himself. So pretty rocking. You can get the book for free, the ebook that is. So just go to this site, dbricks.co/get-ebook, and bam, fill out the little form. It's just a few questions, and then bam, you're going to get all the cool stuff on Spark, Delta Lake, MLflow, and Coalescence, for example. All right. So, and in case you want to dive deeper into the technical issues around why we built Delta Lake, the session will be primarily Spark, so don't worry, but we are going to go ahead and talk a little bit about Delta here as well. We want to read the VLDB paper. So it's right on the delta.io website, so you can go ahead and just grab it from there. So again, same context. I'm not really going to go ahead and bother diving too much deeper than that. All right, perfect. in case you're wondering, who are we? We're Databricks. You're going to see all sorts of this is the one and only marketing slide, so do not worry. We are the unified data analytics platform for accelerating innovation across data science, data engineering, and business analytics. Okay, so that's it for that spiel. Key thing, we're the original creators of projects like Apache Spark, Delta Lake, MLflow, and Coalescence. Hence, you saw with the book just previously. All right, so that's why I would love you to go ahead and download the book, read it, provide feedback, the whole kit and caboodle. All right. Now, if you want to dive deeper into, because this is going to be more of a breadth session, mind you, some of you are going to complain to me to say that this is too deep, but it's more of a breadth session. If you want to dive really deep, there is the session from the Data and AI Summit, a deep dive into new features of Apache Spark 3.0, and that's with Xiaoli and Wenchan. Great session. Highly advise you to go ahead and take a look at that. All right. And then if you want to dive deeper also on specifically AQE, adaptive query execution, we did a tech talk back in December with Marianne and Allison, rock stars to say the least, in terms of being able to explain what they, because they help build AQE in Databricks, okay? And it's all, not just for Databricks, it's also in Spark, but we just wanted to call it out, what they've done, all right? So cool stuff, right? All right. Oh, sorry about that. All right. And then that was a link to the session, so my apologies. I didn't mean to play it. And finally, also another cool session that you might want to check out, Delta Lake 0.7.0 plus Spark 3.0 AMA. Basically, it was myself, Barak and TD. Actually, I'll rephrase that. It was Barak and TD and a little bit of myself that we went ahead and covered questions from Delta Lake, Spark 3.0. Basically, we had you asked your questions and we tried our best to answer them, and I think we covered most of them. So a great session for you to check out. And there's also on the Data and AI online meetup. Okay. All right. So with that out of the way, let's go ahead and talk about Apache Spark. Now with 3.0, oh, by the way, he's just a little worse. No, I'm not. I'm just really, really antsy because I've had too much coffee. Haha. So nevertheless, Apache Spark 3.0, we would go ahead and we saw something on the order of 3,400 JIRAs, okay? Just in Spark 3.0 RC2. And for some of you who are asking for links to everything I sent, once we're done, and we're gonna leave about 5 minutes for Q&A, I'll make sure to copy those links and put them into LinkedIn, okay? All right, so pretty cool stuff. We could try to talk about all this stuff, but honestly, we're not, because we only have 45 minutes to talk about it, and it's going to be a little bit rushed even then. So what we're really going to actually focus on are just areas around performance and the extensibility ecosystem, all right? And like I said, there's a lot of good stuff in Apache Spark 3.0, including richer APIs, SQL compatibility, monitoring, and debuggability. So you know what? It's rocking. Don't get me wrong, it's awesome stuff. But yeah, we're gonna need to really focus on just these two sections. All right. So specifically on performance, we're gonna go ahead and talk about AQE, adaptive query execution, dynamic partition pruning, query compilation, speedup, and join hints. We're probably going to talk about the first two just because there's actually a lot of good stuff here just on that. And Harry, you just asked the questions. The Q&A links, the links, like I said, I'll copy them once we're done the primary session, and I'll make sure to paste them directly into the Zoom for those that are on Zoom versus those that are on LinkedIn. I'll make sure to copy both set of links there, right? All right. So, all right, well, let's start with the Spark Catalyst Optimizer. So for those of you who have played with Spark or work with Spark quite a bit, the context is that, Spark 1.x, that line is, our Catalyst Optimizer was basically rule-based. 2.x line was basically rule plus cost-based optimizer. And now with 3.0, we actually included the ability to perform a lot of tasks at runtime when it comes to optimizing the code. Okay, all right. So what do we mean by this? So for some of you, you may be familiar with this diagram. What you see here is the logical and physical planning that the Catalyst Optimizer of the Spark engine performs. Basically, whether you're running a SQL statement on the left here, data set or data frame, first, it'll go ahead and run an unresolved logical plan to a logical plan to optimize the physical plans, cost model, to select the physical plans, and then at the query execution level, it'll go ahead and create the RDDs, DAGs for that will execute against your data. Now, the important context here is that if for some of you who may have a database background, the database background, you're going to say, hey, this looks a lot very similar to the logical and physical plans that are created within databases. And you're exactly right, right? The context within the Catalyst Optimizer is to bring in some of those concepts directly from databases in terms of, like I said, logical and physical planning, and applying that to Spark. Now, this stuff actually was already available as part of 2.3, okay? If not, it's actually technically even earlier than that, but now I'm thinking about it's more like 1.6, but obviously we improved things over time. Now, the key issue when it comes to AQE though, is that we could do adaptive planning from that logical planning stage all the way to RDD. So every time we can go ahead and look at the statistics and re-optimize the execution plan and improve the performance. That's the most important aspect here, okay? All right, so let's talk about specifically AQE, all right? And there's a by the way, the slides I'm presenting here, by the way, we're going to send these slides out they'll be available in meetup.com, and they're also going to be available in YouTube. And I'll post them directly on my own LinkedIn as well, so you can go ahead and download them and use them yourself. That'll include all the links that you're seeing here, by the way, okay? So the AQE fundamentals, we're going to talk about three things, which is dynamically switching join strategies, coalescing shuffled partitions, and dynamically optimizing skew joins. Okay, and that one I'm a huge fan of. If you're ever working with databases, you often find that when you have skews in your data and you try to do a join, it becomes excessively inefficient. Well, Spark 3.0 has a pretty cool way of solving that particular problem. And if you're wondering how it is, the TLDR is subpartitioning beyond belief. Okay, so let's start with broadcast hash joins here in that case, okay? So when you do your joins and shuffling, right? Initially, what you're worried about here on the left side is basically that you're trying to join one table, and then you have your fact table spread across multiple nodes. Sorry, the orange are the nodes, and the green basically is a table you want to join against, a smaller one, while the dark gray, I guess, or light gray, excuse me, is your fact table distributed across multiple nodes. Now, when you're doing the joins and shuffling, what you end up having here is basically one join table, the smaller table on one node, while your fact table is across 4 nodes. And so you're starting to saturate the network to get the data from the join table across the network, okay, to each individual portion of the fact table. All right, so now let's flip it around. If I do a broadcast hash join, good old-fashioned Spark SQL auto broadcast join threshold, the join table's replicated across multiple nodes, and then I'm able to go ahead and do the join intranodally as opposed to across nodes. So that way I'm actually reducing any of the shuffling in terms of, especially from a network perspective, okay? So that's pretty sweet, all right? But then you're gonna automatically ask me questions like, hey, well then, dude, why not just always broadcast join? Like why just that is not the default? Well, there's lots of things like missing or incomplete statistics, compressed files, is it in a column store, complex filtering, UDFs, complex query fragments, okay? So because of these things, we cannot automatically do it, even though, candidly, for a lot of my queries, I just automatically do that, all right? So the context when it comes to AQEs, that one of the fundamentals is that you can dynamically switch your join strategies, okay? So for example, when you start with a sort merge join, right, here on the left, right, you do your sort and your shuffles. For stage 1 of one table is an estimated size of 100 megabytes, all right? And then on the second side, the other table, you use sort, shuffle, filter, scan, its estimated size is 30 megabytes, okay? Well, when you execute it and you actually run the logical and physical plans, what you'll recognize, and I'm using this particular example, actually the table initially is now, instead of 100, it's actually 86. The smaller join table is actually 8 megabytes, so it's even smaller, i.e. potentially small enough where you can automatically broadcast it. So At 30 megabytes, maybe the table was too big for us to broadcast, but at 8 megabytes, it is. So the idea of AQE is that it's actually able to go ahead and say, hey, we noticed that our original estimates or original statistics were not quite right. Let's go ahead and flip the switch and now recognize the fact that we can actually do a broadcast choice. So that's actually what ends up happening. So instead of using the default of a sort merge join, we can optimize it mid-flight, switch to a broadcast hash join, because the smaller table, the join table is actually 8 megabytes, so it's within threshold in this particular example, and then bam, you're good to go, right? So as opposed to you needing to run a query to determine if it can actually handle that, and then you flipping the switch, AQE automatically does that for you. So yes, Manish, you're asking a question, you're basically optimizing the joins. That's exactly what we're doing, okay? All right, so the second part is dynamically coalescing shuffle partitions. Now, here's always a fun one. And for example, I'm going a little off script, but for example, if you look at the past, when you ever do a join, we automatically in Spark go ahead and do like 200 partitions. And people are going like, wait, why is it always 200? And honestly, I've long since forgotten how we even got there. So in fact, if you know, let me know, because I've forgotten how we did this. But nevertheless, when you look at your data, right, if you've got these two tables, which is premised on map 1 and map 2, if you're not coalescing your partitions, because they're in essence 5 partitions to the data, there's a lot of shuffling back and forth between the two mappers. And so that way, when you run your reduce, you have 5 different reductions. Okay, cool. All right, so that's how it runs normally. How about if I can coalesce the shuffle partitions? What do I mean by that coalescing? It's sort of, you can see this diagram. Notice how I guess it's light yellow? Yeah, light yellow, blue, and light blue partitions are smaller. So since they're smaller, why don't you just coalesce those 3 partitions together? So instead of having 5 reducers, why not go ahead and chuck it into 3, right? So you've got 2 mappers, now you have 3 running 3 reducers. Because it's doing that way, you're shuffling a lot less. So even if you do have network saturation, it's going to be a lot less as opposed to 5. Now I get down to 3. All right. Oh, and by the way, Manish, your question about how does the optimizing joins actually affect the table size? It doesn't. What I was referring to in this section here was that we estimated the size of the tables initially, right? And the estimation was 100 megabytes and 30 megabytes. But when you run within the Catalyst optimizer from that logical to physical plan that you had seen here, like this part here, when you go through that step, you'll find out the fact that, oh wait, you know what? No, the table sizes are actually not 100 megabytes. The actual size is 86, and the actual size of the join table itself is 8 megabytes. And for sake of argument, our broadcast threshold is at 10 megabytes. So it's smaller than it's below the threshold. So since it's below the threshold, that means the table will automatically be replicated when we use broadcast hash joins. But instead of you needing to specify that fact, AQE with Spark 3.0 automatically does that for you. So that's pretty cool. That's the context. Okay. So hopefully that answers your question. So now back to the coalescing of shuffle partitions. Exactly as I say, right? We have all these partitions. Can you coalesce them together so that way you have less reducers? Cool. So that's what the AQE. All right. So now to put the two together, we have a really cool feature about dynamically optimizing skew joins. All right. That's the cool stuff. All right. So this is a time-old data warehousing database problem that we've seen forever. And by the way, the person who asked about, can I pass hints to optimizer? You absolutely can. Give me a couple more slides and we're going to go ahead and pass it through. Okay. Sorry, not pass it through. We're going to go explain it. Sorry about that. All right. So with a traditional problem, for example, I have in red, the data is skewed. So for example, think about old fashioned data warehousing problems where that particular value is null. okay? Or that value's negative, or if you're old, even older school like me, you'll flip it to -1, okay? So the idea is that, okay, all my values for this particular widget color is -1 because I don't know what the widget color is. So that means what's stored in the fact table is a bunch of -1s or nulls, okay? And so that's what this table A part 0 is representing. Table A is the fact information, and there's a heck of a lot of -1/nulls inside them. All right, well, that's your standard skew, okay? And it's really, really, really common in data warehousing, and for that matter, even databases. Okay, so it's ugly, and so what ends up happening is when you try normally to go ahead and do those queries, you'll notice that, okay, great. When I try to shuffle, the yellows are the orange and yellows are more or less together in terms of partition 1, the different partition 2, in terms of what cyan, like green. I'm sorry, I'm actually partially color deficient, so I can't tell the colors, and I actually chose them, so my bad. But the idea is part 3, you're good together. But whoa, table A, part 0, partition 0, table B, partition 0. Yeah, we're really far off. So in other words, partitions 1, 2, 3 will complete extremely quickly, while partition 0 is going to take a really, really long time. So how do we solve this particular problem? Well, you solve it. Oh, there you go. Okay. You solve it basically using the same concept of AQE, right? In terms of we look at the actual, try to do a sort merge join first. We execute, we get what the reality is, the actual sort merge join, right? So remember, in the previous slides, we were going estimate size, then true size. So same concept. The left one here's estimate. The middle one is true. But when we go to the right, there's an additional of a skew reading. All right. So it actually figures out how to deal with skews specifically. All right. How does that turn out? Well, same idea as we've said before, where we on the left side, we have your skewed table A. All right. If you look in the middle, that's what your table A partition 0, that's really big. All right. Now, what we do is we split that. So table A now gets split into its own set of sub-partitioning. So we're deeming this as split 0, split 1, split 2. So in this particular example, we're just breaking table A into 3 of its own partitions. Okay, so table A part 0 is now broken up into 3 of its own partitions. That's why we have the splits. Table B is itself, since it has its own partition 0, we replicate that. And so that actually is happening all underneath the covers. So now instead of actually having 4 partitions, quote unquote, in where one of them is larger than the other 3, so that means those 3 will go ahead and finish faster, okay? Well, the first one's going to take way too long to finish. What ends up happening is I've got 6 sets of partitions, okay, in total, right? Yes, it's partition 0 with splits, but what we already have is the 3 sets of partition 0s and the 3 other partitions, partitions 1, 2, and 3. You put those together, now I have 6 partitions. They're all roughly the same size. And because of that, they're all going to complete roughly at the same time. So significantly faster. In a nutshell, that's what how Aqe Fundamentals, as part of Spark 3.0, handles skew joins. And the performance, now this is an older graph because when we ran this, it was actually on DBR sum.0 beta, okay? Beta, i.e. as in the early release. Right now, just to provide some context, as of today, we actually just released DBR 8.1. So it's a later version of Spark with other additional optimizations, but the key context is what you see in this graph here. With AQE off, which is the blue color, and then AQE on, which is basically that orange color, you're going to see significant performance improvements by turning AQE on. And so by default, having AQE, adaptive query execution, fundamentally improves the performance of your queries. Okay, so that's why we're going, yeah, let's use Spark 3.0, because
this is really rocking. Oh, by the way, I'm sorry, I should have probably mentioned, these are just select queries from your TPC-DS. So your standard DS TPC workload, okay? All right, so that was just AQE. So that was a heck of a lot of stuff. I just went ahead and reviewed. If you want to go dive deeper, there are links inside these slides, which, like I said, I'm going to send the slide deck out for everybody to go ahead and so you can get access to all of those links. Okay. There's a session by Marianne Allison on faster Spark SQL with AQE, and also they wrote a really good blog. Both links are inside these slides. And so if you want to dive deeper, I would highly recommend you diving into to reviewing those things, okay? All right, now I'm going to change gears big time, all right? Oh, sorry, let me take a second just to take a look at some questions here. Okay, so there is a good question on Zoom in this case about how do you know the statistics and then decide, does it mean you actually execute the query twice? Yes and no. Okay, so you personally are not actually running the query twice. You're running a Spark SQL query or a data frame query using Spark 3.0, and Spark 3.0 just handles that for you. Okay, so that's actually what's happening underneath the covers. Underneath the covers, though, okay, we are in fact actually running the query multiple times based on updates and statistics, right? It's basically a feedback loop, right? As you're going from the logical planning to the physical plans themselves and the execution of those physical plans, go ahead and it basically goes back and forth, back and forth, back and forth, all right? So, oh, sorry guys, can you still hear me okay? Because it looks like some folks are telling me that my micro audio is muffled.
We hear you okay. We hear you okay. Just a little bit muffled.
Why? These are just my AirPods. So let me, how about if I switch to this way? Does it sound better now?
A little bit better. It's not too bad.
Switch to this mode for now and see if that actually helps. All right. So anyways, what I was, so thanks, Harry, for calling that out. I apologize for any of the, in the muffling sound that you might have heard. Could just be my voice anyways. But nevertheless, the context is that when you are doing this, when you're running those queries, basically underneath the covers, yeah, we might run it multiple times to basically improve things. These are happening in parallel and extremely quickly, so that's why you're not going to hear it. But what it boils down to is that that's the whole reason why we have a logical versus physical planner as it is anyways, okay? So hopefully that sort of answers your question. Frankly, we're probably having to dive deeper. There's actually a really good blog post that Reynolds Shin wrote about how Apache Spark is a compiler. So if you look, just Google Bing it, right? Apache Spark as a compiler, you can dive into the details of what I mean by how that logical physical planning works and how it actually determines those plans, okay? All right. We have a lot, so let me go ahead and talk about a little bit, at least about dynamic partition pruning. So dynamic partition pruning achieve high, as it calls out, with dynamic partition pruning, we can actually get faster performance for all your workloads. Okay, so using TPC-DS with your queries, with or without DPP. Again, DPP is dynamic partition pruning. Okay, then what ends up happening is that with the green is with it off, and the red is with it on. And so you can tell from this that the query speedup is somewhere between 2 to 18x. So we're talking about significantly faster performance, all right? So that's pretty sweet. And so again, part of the reason why you want to consider Spark 3.0 is because of dynamic partition pruning as well, okay? And so how does that work? All right, well, let's talk about how DPP worked before the actual optimizations. All right, so we're looking at a query, which is select table 1 ID, table 2 partition key or P key, okay? From table 1, join table 2, you're going to join by the P key. I'm just going to say key because P key sounds weird. All right, and you do some little filtering. All right, well, what's happening underneath the covers is that we do a project specifically on that join, and then we do the join on the key. All right, And then we can do a scan on table 1 because it has a large fact table with many, many partitions, okay? And then where we can optimize those, we do the filtering, which is table 2 ID is less than 2, and then we scan, right? So in other words, instead of running the join first, we filter the second table, make it smaller, then do the join. That will run things significantly faster. But before the optimization, that's not happening, okay? So just like I was implying before, instead, when we do the actual optimize, again, project, then join for between the two keys, but then we do a filter scan, filter push down to get table 2 to be significantly smaller. In the process, we also go ahead and say, hey, what table 1 keys are in the scenario of select table 2 key from table 2, all right? So in other words, not just filtering table 2, but filtering table 1. So table 1 is smaller, and then only then do we do the scan, all right? So we significantly reduce the amount of time we're scanning because we've already pre-filtered the data in the first place, okay? So let's see, all right. So then once we do that, all right, the basic mechanisms here is that you're inserting, by the way, I'm sorry, not you, Spark 3.0 is inserting a duplicated subquery from the other side, all right? The table to prune is partitioned by that join key, just like we called out, and the join operation, provided that the join operation is one of these 4 things, right? It's an inner, left semi, left outer, or right outer, okay? So it covers many of the use cases that you really care about when it comes to joins anyways. So boom, you should be good to go on that front. All right. So now, because we can do that, we can push. Now I'm going the other way, so I apologize for the way I wrote this particular slide. But the optimizer is going now this way. All right. And then basically we are doing the filter and scan, the scan that's required for table 2. We're doing the partition key or the key from table 1, which is in the DPP filter results. So now it's a filter scan, okay? And so then finally, what results in is that a significantly faster response time. And what I mean significantly faster, in some of our cases, we saw 33x performance improvement. So pretty sweet, to put it rather lightly. All right, so with this together, that's why we suggest, hey, if you're able to go ahead and do this, by all means, go ahead and use Spark 3.0, which I'm in Dynamic Partition Pruning. Okay, so there is a question from LinkedIn here that is asking, why is Dynamic Partition Override support removed from Delta Lake? It's because it's not so much, we are still debating back and forth on when we're going to want to put it back or how we want to put it back. But don't forget, DPP, Dynamic Partition Pruning, in this case, is actually about how you're working within the context of Spark itself, not so much on how you're going to write the data to disk, right? The fact is, you still will need to put the full table to disk because you want to keep state of it, right? Your one query wants to go ahead and say table 2 ID is less than 2, but subsequent queries may or may not have that, right? So that's the reason why you're going to go ahead and want to keep all of that data. But the key context is that for those queries, now you've got like basically a 90% less file scan, and then hence significantly improved performance. All right. So we've got only a little bit of time left, so I'm going to pseudo rush through this. Okay. So now join hints. All right. One slide, hopefully it covers everything for you. Okay. So these are in order of performance. Okay. So broadcast hash join is the fastest. So then you have your sort merge join, then you have your shuffle half join, and then you have your shuffle nested loop join. Okay, well, can you put in hints? Absolutely. So the context is that you can go ahead and put hints like this, like where you say select plus broadcast a ID from a join, right? You can put hints like this to improve, to specifically specify that I already know that the table sizes are small enough, so let me go ahead and use a broadcast session, or I already know X, Y, and Z, so I want to use a shuffle hash join or whatever else. But the context is that a broadcast hash join is awesome. We try our best to use this one if possible. all right? Which basically, but it requires one side of the table to be really small, no shuffle, no sort, super fast. So that's awesome. The reason we default to sort merge join often is because it's really, really robust. It can actually handle any data size. You do need a shuffle and you do need to sort the data, okay? So if the data is small and you don't need a sort, then in fact, you want to use the broadcast hash join versus using a sort merge join. But if you don't know what's going on, like in terms of what if the data needs to be sorted or if you don't need a shuffle or whatever else, then guess what? You can just use the default of sort merge join. Now, you can potentially also use a shuffle hash join, all right? Because the context is that I'm saying I need to shuffle it, but I don't actually need to sort the data because for sake of argument, the data that you have is already in the correct sort order or you don't care about order at all right? But the reason why it's really cool is because it can really, by doing it this way, you can really handle really, really large tables, including large tables on both sides, not just a small table and a large fact table, like a small dimension table, but two larger tables that you need to join. Key problem, of course, is that you will run into out of memory errors if your data is skewed. And that's usually a problem, by the way. So you got to be careful about that one, all right? And then finally, a shuffle nested loop join, i.e. it's a Cartesian product, okay? So you're not actually joining by key, you're just doing a Cartesian of those two tables. There are absolutely some scenarios where that makes sense. So of course you can go ahead and explicitly go ahead and say that you want to do a Cartesian product of the tables, and then you can specifically specify the shuffle nested loop join, okay? Because that'll go ahead and help that run a little bit faster as well, okay? So like I said, the slides, for all the folks that are asking whether in Zoom or in LinkedIn, these slides, we're going to save them, post them on LinkedIn, we're going to post them on the Meetup, and we're going to post them on YouTube because they're actually on YouTube right now as well. So we're going to post them in all these locations, so you're more, so you'll have all the links of all the stuff I have here. You'll have it. So that way, because I just realized there's a lot of links here, so maybe I don't want to just paste them directly, okay? But as an FYI, that's what we're gonna go do. And when this is done, I'll make sure to keep this window open. So this LinkedIn video will actually, I'll paste the slides into here as well, all right? Okay, so let me go on. Tons of other stuff here too. Extensive building ecosystem. There's a lot of cool stuff like data source v2 with catalog support, Java 11 support, Hadoop 3, Hive 3x Metastore, Hive 2.3 execution. I'm actually really going to focus pretty much on the data source side of the house, okay? Because that actually allows me to segue into Delta Lake and why I wanted to cover about data lake reliability, okay? So the motivation for data source API is that it allows compatibility that's dependent on the data frames API, the upper level, and when you cannot leverage the data set API for whatever reason, okay? What the context is the physical storage information, partition, sorting, is not propagated from the data sources. And then because of that, the Spark optimizer can't actually use it, all right? And so with the original data source API, the first one, the extensibility was not good and the operator push-down capabilities were limited. They lacked columnar read interface for high performance, and the write interface did not support transactions, i.e. ACID transactions. So for those of you with the 15 minutes or so left that we have, you're gonna say, hey, are you talking about ACID transactions? And the answer is yes, we're talking about ACID transactions. The idea that you can protect your data when it gets written to your cloud object store. All right, why do I call that out? Well, because often when you're running your Spark job, especially when you're dealing with large amounts of data, if a task ends up failing, now the good thing about Spark is that it can roll it back or it can retry. But how about if it actually wrote it to disk and only did partial writes? All right, partial writes can be really a bit of a pain to say the least, right? So that means you might actually have to go clean up the data yourself. Well, if you actually had ACID transactions to protect the data, then you could actually avoid that problem because either the data has the partial writes never happened, or even if the partial writes did happen, there's a transaction log that details which files that you need to read. So even if there was a partial written file on the storage itself, we would never read it because the transaction log says, what am I supposed to go ahead and go do? All right, so that's what we're going to focus on, obviously. Okay, so with the catalog plugin API, right, users can register the customized catalogs to use Spark to access and manipulate the table metadata directly. So in other words, your good old-fashioned create table, alter table. So good stuff. Loving that. All right, cool. Now, by the way, we're actually on Delta Lake 0.8. So, but the reason I'm calling it 0.70 is because it's the first release, which is support for Apache Spark 3.0. Okay, and it adds support for those metastore defined tables and SQL DDS. All right, so as opposed to just these, now we can do all of these. Okay, so support for SQL, delete, update, and merge. Right, it's not just for inserts anymore. Right, and so that's what's really cool about this. So in other words, for those of you who are much more into database data warehousing type of perspective of things, where you'd love to be able to write SQL statements for updates and deletes, guess what? Now you can, and that's what's awesome here. All right, and so what's actually happening under the covers? Because remember, I said that I was worried about partial writes, I'm worried about transactions, all these other things. So for example, when I'm doing a delete or an update or merge into, what's really happening underneath the covers? So let's talk about it. Let's talk about a delete in this case. Okay, I want to delete this little bit of yellow here. Okay, so that's what the V1 of the table is. So what I have is I have a bunch of files, all right, that represent the table, and that's my version 1. I need to delete 5 rows from this table. Those 5 rows happen to be in a file. Okay, so what I need to do is delete, quote unquote, the rows, which implies I'm trying to delete the file. Except these systems, especially like Spark, and for that matter, any distributed system, they tend to be additive. So we're not actually going to just simply open a file and remove the data from it. What we do is we go ahead and simply say, okay, the V2 of the table is simply all of the files added in that we didn't delete. Okay, so traditionally in the past, what I have to do is instead of actually running a delete statement, I would basically say select all the data except for the data that I didn't want to delete and insert that into a new table. Okay, but underneath the covers, we're almost doing the exact same thing, except you don't have to do any of that. You just simply write delete from events, and that's it, right? So that makes things significantly simpler. And now we can definitely dive in much, much deeper. So I'm going to go ahead and actually skip a lot of that stuff, honestly, because we have other sessions for that. But the context basically is that because what's actually happening on the covers is that we'll recreate and copy the new files. For the file that contains the 5 rows we delete, we're going to recreate that one file, right? And only that file. So we filtered it down. So as opposed to recreating the whole table, we just recreate that one file, but except it has a new GUID or whatever, and it actually contains all the rows but the 5 rows. Okay. And so what's happening in the transaction log is that, first of all, let's just say there were 4 files that represented the table. Well, then now there's these file A, B, C, and D that's in V1. All right. Well, now because I take, let's just say file C, that's the one that I need to remove 5 rows from. So now I have a C1. So now for V2 in the transaction log, I have file A, B, C1, and D. So I didn't actually have to replicate all the data in file A and file B or file D. I only had to replicate part of file C. And so that's going to C1. So inside the transaction log, that's what I have. I actually have A, B, C1, D, not just A, B. So I'm not truly replicating all of the data. Okay. So that does speed things up, all right, significantly because of that. All right. What happens when I actually want to go back in time? For sake of argument, I've inserted data, I've updated data, but now I need to go ahead and realize, no, I screwed up. For sake of argument, V3, I didn't insert because I added the yellow, the brighter yellow here. And V4, I realized, hey, I want to do an update. Okay, that's cool, right? What ends up happening is that if I want to do time travel or data versioning, I can just do select star from events as a version, using version as of 2, and I can go back to V2 and just get the files A, B, C, 1, and D from it, even though by the time it's V4, it's probably like A, B, C, C1, D1, E, F, G, H, O, whatever else, right? That's the context. All right, now, somebody asked a question, which I'm sure is a good question here. Did I have to scan all the files? Yes and no. The reason I'm saying yes and no is because the transaction log itself tells me already what files. It actually literally lists the files. So for example, I don't actually have to do a file listing. I already know exactly which files to go ahead and stack. Because there's statistics also inside the Delta transaction log, depending on for example, if I use delete, let's see if I had the delete statement here. Okay, if I do a delete from statement where like ID equals 2 and ID is actually partitioned, all right? Then what ends up happening is that I have statistics that'll tell me which partitions or which files I need to read, as opposed to I don't need to scan all the files, all right? So that's why I'm saying yes and no, right? So if I'm using a more broadly query, or there is no index for me to reference, or there's no additional statistics or metadata for me to hit, you're right, I potentially will need to scan all the files. But if there is metadata or partitioning or statistics that I can reference, then in fact, I don't necessarily need to scan all of the data under the covers, okay? To be able to do all this, basically, as a quick call out, there's some important things about, well, that means I've got a history of data, right? So because even if I'm able to be efficient about instead of replicating all the data, I just know go C1 from C to C1, over time, there's a lot of data. And not just data, over time, there's a large transaction log too. So these are two very important history retention commands, all right? So basically you can alter them so that way, when you execute a vacuum statement, it will clean up all the old data. So in other words, if you're on version 20 of your table right now, and that version 1 is from, let's just say, 2 months ago, well, yeah, maybe you just run a vacuum and clear out any data that's older than X amount of time. By default, 7 days, but you can change that time as well, okay? That's what the context of all these particular commands are for. Okay, one's for the log, transaction log itself, the log retention duration, and one's for the actual data itself. Okay, all right. Let's see. All right. Well, and then because we enabled data source v2 and catalog API integration, right? These were important so that way, when you're working with Spark and Delta Lake, you're actually able to run all of these commands, all right? It was in order for Delta Lake to work with Spark 3.0 correctly, all right? We need to reference the catalog APIs and data source v2. So enable these configurations, enable these extensions, and then you are good to go, all right? Let's see. And then what little tidbit, the data quality framework is just in terms of improving SQL DBLs and DMLs and ACID transactions are just the start. Basically, the last little tidbit, it sounds like I'm doing a little bit of salesy thing, but I really am not. It's about more or less the lakehouse paradigm. The whole premise is that you want to have improved performance, data warehousing-like capabilities, but on your low-cost cloud object stores. Right. So for us to do things like adaptive query execution, dynamic partitioning pruning, query compilation speed up, join hints, and so forth, with Spark 3.0, you significantly improve your ability to do ETL machine learning query performance using Spark 3.0, right? That's why the community, we're constantly adding all these different things. And then in the case of Delta Lake, we add that in order to ensure ACID transactions to your data. In other words, if there are errors, if there are issues, if I want to run multiple streams directly to the exact same table, no problem, because Delta Lake actually allows me to go do that without any problem, all right? So it's a combination of those two things together that really allows me that capability. That's more the context we're talking about here, okay? If you want to know more about Delta, obviously go ahead and go to delta.io. And then final set of links, try out Spark 3.0 and Delta Lake now. You can try out Spark 3.0 right from the Databricks Community Edition. That's free. So databricks.com/try. Obviously, if you want to download it, just go to spark.apache.org to go grab that. We have a lot of cool notebooks on how all this stuff works. So try out the notebooks. They're available at GitHub/Databricks/Tech Talks. And again, we're going to go ahead and give you these slides so you can go ahead and reference all this stuff. This session here is actually part of the Seattle Spark and AI meetup, not actually part of the Data and AI online meetup, but we're actually using some of its references because Karen runs the Data and AI online meetup. I'm just one of those guys who happens to be a fan of the Seattle one, so that's why I'm here. So there you go. Go ahead and check out all those cool sections there. You can also get the ebook. Again, we put the link inside there, and the paper, the link inside here. So I'm going to leave it at that. We've got about 3 minutes left in terms of questions, so I will try my best to answer the questions. But the first thing I'm going to do is I'm going to go ahead and look for the slides real quick, and I'm going to paste this into both the LinkedIn and the Zoom channels, so that way you guys can go ahead and have the slides right away. Because I believe I put a version, maybe a slightly earlier version of the slides, but I can update those. So give me 1 second as I do that. All right. And meanwhile, if you do have questions that are not slide related, by all means, please go ahead and let me know and ping me about it. Here, perfect. I think, yes, I do. Haha. All right. So to those folks I'm about to send the slides here to Zoom, and now I'm going to send them here to LinkedIn. I'm going to actually update them because I did some updates, but it'll be the exact same link that I just sent you. So you can go ahead and just grab the slide. So I'm going to, like I said, I'll since I did do a small update, I'll actually add a couple links here. All right. So let's see. Let me look at the remaining questions. From the Zoom, I've got a question on how do transaction logs look and recovery techniques. So that's a very point. There's a lot of potential answers to this particular question. So the long story short is this: the transaction log contains every single file that you possibly need to read for your table. Okay. So because it does, and it has multiple versions, if there are errors like oops, you can always roll back, right? And that's what you basically run a rollback statement, or just a select from a version and insert overwrite, and boom, you've brought your table back. Okay. Now, in terms of recovery techniques, you can always either roll back the table itself, or like I said, overwrite the table by doing select from version as of and then insert overwrite. Or you can also potentially clone your tables. So for sake of argument, you can clone the tables, put them into a like colder or cold storage or warm storage. So that way you can actually have a different copy of the table to work with. And for that matter, one interesting aspect that we've recently been talking about is actually ability to, in essence, treat your data like an artifact. So it's not just, you know how with GitHub, you're treating your code like an artifact. Well, the idea is not just treat your code as an artifact, treat your data as an artifact. So what do you do in GitHub? You'll often fork or branch the code so you can make modifications to it. Well, same idea with Delta Lake, with Spark 3.0, those two together. Spark 3.0 obviously gives you the performance aspect of things, but what you can do with Delta is you can clone the table, i.e. similar to you branching or forking the table, and do your modifications directly against that table first while you do not mess with the production line table. And then once you've determined that this is exactly what you want to do, then you can go ahead and actually merge the changes back together if you want to. And what's great about it is that it's not just merging the code changes back together, you potentially can even merge the data changes together because we keep versions of the table intact. Okay, so hopefully that answers your question. And I'm going to answer one more question from LinkedIn. Is Delta Lake an alternative to Kafka? No, it's absolutely not. Delta Lake is about file storage. Kafka is an awesome system. Love it. Would never insult Kafka. It's there for the purpose of your streaming, for your streaming environments, big time, right? At some point, you're going to need to go ahead and land the data. Okay, that's it. You're going to need to land the data. So when you have to land that data and you want to keep session state of that data, that's what Delta Lake's for. In other words, Delta Lake underneath covers, by the way, I realized I probably should have covered this earlier. It's like your Parquet table. That's it. Like it literally, that's all it really is. It's just your Parquet table. It still uses Apache Parquet, whatever codec you want to use, Snappy codec for progression or whatever else, same context, same everything. So we're good to go on that front. So instead, what it is that we have a transaction log with those Parquet files. So that way you can go ahead and track each and every file that lands in there, right? So that's why we're saying, no, it's definitely not a competition against Kafka. I mean, I think the only way I can be competition against Kafka is if you decide that you really want to hold 3 months worth of data in Kafka. Probably not the best idea. Okay, I mean, if it's small, you can probably do it, but generally you probably don't want to do that, right? Kafka is well designed for what it's for. In this case, we're talking about storage. All right, so I apologize for not answering all of your questions, but that's it for today's session. It's 3 minutes to the hour, so I did want to wrap things up. So again, thank you very much. We will, Karen already sent a link to the YouTube link. So that will allow you to go ahead and see this recorded as well. Obviously, this LinkedIn link that you're using right now will work perfectly fine. For those that are on Zoom, like I said, the link will be sent there. We will have another Seattle Spark and AI meetup that follows up on this session, except it's specifically demo heavy now. So in other words, that's what I want to leave you. So I provided a lot of context on how to conceptually run the stuff. The next Seattle Spark and AI meetup is going to be demo heavy about how all this stuff runs. And yes, if you're wondering, it will include notebooks that you can download. Okay. So again, thank you very much. I appreciate you taking the time. Please ping me in LinkedIn or on the YouTube if you have any other questions. That's about it. And thanks very much, everybody.